Hi everybody. Today my topics is first order linear differential equation. As we know, simplest first order differential equation is dy by dx equal to qx. We solve this type of equation simply by integration. For an example, solving dy by dx equal to x square, we do integrate both sides and get the general solution as y equal to 1/3 x cube plus c. More generally, a first order differential equation is called linear if it is expressible in the form of dy by dx plus pxy equal to qx, like this one. Here our first equation dy by dx equal to qx is the special case of the equation number 2, this one. And equation number 1 results because we assume px equal to 0. We will assume that the function px and qx are continuous on a common interval, and we will look for a general solution that is valid on that interval. Now, if we notice that the differential equation is not separable because it is impossible to factor the expression for dy by dx as a function of x times a function of y, but we can still solve the equation, and it is by product rule. Multiplying both sides by a positive function, say ix. What we get? We get a transformation of the left hand side of this equation into a derivative of the product of ix and y. We can see it here. Now we have to find ix, integrating factor. Then we'll see how it provides solution. If we assume diy by dx equal to this, right away we can write dixy by dx equal to ix qx, and integrating both sides with respect to x, we get ixy equal to integral ix qx dx. Here we can write by simplification y equal to 1 by ix integral ix qx dx. This equation expresses the solution of the general equation in terms of the functions ix and qx. This qx, this ix, is an integrating factor for the first order linear differential equation. And most importantly, its presence makes the equation integrable. This is very important point. Now we expand equation as diy by dx equal to I dy by dx piy. Now applying product rule, we can write equation like this. And from this equation, cancelling I dy by dx from both sides, we are reaching on this y di by dx equal to piy. With more simplification, we get di by dx equal to pi. And separating variables, it becomes as di by I equal to p dx. We can see it here. Now integrating both sides, we can find ln of I equal to integral p dx. Taking exponent on both sides, we are getting very important formula of integrating factor, and it is I equal to e to the power integral p dx. It's very important formula. Now at an end, as a gist we can write, we can say, to solve linear differential equation, multiplying both sides of the standard form of linear differential equation by integrating factor ix equal to e to the power integral px dx, and then we have to integrate both sides to get the solution of linear differential equation. Here we took one example of linear differential equation, and it is dy by dx plus 4y equal to 4x. What is the general form of this equation? We have to compare this with the standard form of the linear differential equation. Why we'll compare? Because we need to identify the position of px and qx in the given equation. And after identifying, we find that px equal to 4, qx equal to 4x. Now we shall find integrating factor if using the formula. It is equal to e to the power integral px dx, and px value is 4. Putting that value, we get the result as e to the power 4x. And one important point is to use the formula for the general solution, and it is this one. Substituting the value of ix and qx in this general solution, we find equation like this one. Now we have to use integration by parts to find the integral of this value. So integration by parts formula is this one, and in this case we have to assume that u equal to 4x. So we get du by dx equal to 4. Once we get this value, through simplification, we get du equal to 4 dx. Now we have to find the value for dv, because this one is u and this one is dv. So if we write dv equal to e to the power 4x dx, then integrating both sides, we get the value of v right way 1 by 4 e to the power 4x. Now substituting the value of u, v and du, we get the equation as this one. And simplifying, it becomes as this. Thus the general solution is this one. How it comes? This value we have to put it here, and with more simplification, with more simplification we get this one. This is the general solution. Now at the end, I can say that our linear differential equation was this, and we got the general solution as this one. Second example, linear differential equation is 2dy 6x square y dx equal to 6x square dx, and we have to compare this equation with the general form or standard form of linear differential equation. But our main equation is not like the previous one. We have to do some additional thing to bring it into this shape. So what we will do? we have to divide both sides by 2dx. So this equation appears like this. Now we can identify px and qx. How? Seeing the position of this px and qx, right away we can write px equal to 3x square and qx equal to also 3x square. Now integrating factor, we know the formula, e to the power integral px dx. Putting this value, we get result as e to the power x to the power 3, I mean x cube. So our general solution for a standard form of linear differential equation is this one. Now putting the value of ix and qx, it appears like this. Now we have to apply, that is called integration by substitution, to solve this integral. We have to assume z equal to x cube, then we get dz equal to 3x squared dx. Substituting the value, we get this at an end, our result is e to the power x cube. This value to be kept here. Then we get this general solution. With more simplification, it comes like this. So we can say for our linear differential equation, this one, what we had here, our general solution is y equal to 1 plus c divided by e to the power x cube. Here our linear differential equation is x dy bracket 4x plus 3y bracket dx. To solve this equation in the same way, we have to compare this equation with the standard form of this one. Reason is to identify px and qx. Now to bring the given linear differential equation to a standard form, we have to divide both sides by x dx. And after dividing, it looks as dy by dx minus 3y by x equal to 4. Now comparing position of px and qx, we can write px equal to minus 3 by x and qx equal to 4. Now using integrating factor formula, we can write ix equal to e to the power integral px dx, it means minus 3 by x dx, and through simplification this way, then this, at an end we reach at 1 by x cube. As we know, the general solution for a standard equation is this one. So we have to put the value for ix and qx, and after putting the value of ix qx, it appears like this one: y equal to 1 by x cube integral 1 by x cube 4 dx plus c. And more simplification, we reach at this point, I mean y equal to x cube in bracket 4 by minus 2x square plus c. So we can do more simplification on this, and the general solution becomes as y equal to cx cube minus 2x. Now to find the particular solution, we have to apply x equal to 1 and y equal to minus 4. If we apply this, right away we can find the value of c, it is minus 2. So substituting value of minus 2 in this general equation, I mean general solution, we get the particular solution as this one, y equal to minus 2 bracket x cube plus x. And at an end, in gist I can say linear differential equation, we had dy by dx minus 3y by x equal to 4, and solving we get a general solution y equal to cx cube minus 2x, and we got particular solution as y equal to minus 2 into x cube plus x. And that's all for today, and thanks for watching.